There are the solutions to 1 through 15. Go ahead and pause it and check yours to make sure that uh, you know which ones are which. Number 16 says find the height of a right cylinder with a radius of 9 centimeters and a volume of 567 pi cubic centimeters. Remember the volume for a cylinder is pi r squared h. Okay, so we know we've got a total of 567 pi. R is 9, so it's going to be 81, and we're solving for h. So now I need to divide both sides by 81 pi. That'll go away over here. Divide by 81 pi over here. And that will leave me with h is equal to 7. Okay, so C is your answer there. Working down here on 17 and 18. Okay, I'm going to find total area and volume. Remember, total area of a prism is your lateral area plus 2 bases. And lateral area is perimeter of your base times your height of your prism. So if I'm looking at my pyramid, or not my pyramid, my prism over here, the base is the trapezoid. Okay, so it has one base of 7, one base of 12, and then the sides are both 6 and 6. Okay, or the legs. So the perimeter of my base is 31. Now the height of my prism is 18. So it's like 31 times 18. That's perimeter times height. I get 558. So 558 option, I'm sorry, lateral area is 558. Okay. Now notice that that is one of your options, but we're finding total area, not lateral area. So I need to add to that 2 bases. So let's find base. That's 1/2 the height of the base times the sum, or sorry, the height of the trapezoid, which is the base, uh, times the sum of the bases of the trapezoid. So we get 1/2. The height of my trapezoid is 5.5. Now the sum of the 2 bases of my trapezoid is 19. So I'm going to take 1/2, multiply it by 5.5, and multiply that by 19. And that gives me a base of 52.25. Okay? Well, I want 2 of those, which is 104.5. And then I want to add to that my 558 from my lateral area. Okay, so 104.5 is 2 bases. 558 is lateral area. Add those together, you get 662.5. So option C is my answer there. Volume is base area times height. Okay, well, we just found the base area. I'm going to go back to my calculator. Base area was 52.25. So 52.25 is capital B. Now times the height of the prism. The height of the prism is 18. So I'll multiply that by 18. So 52.25 times 18. And the volume of this thing is 940.5, which is option A. All right, so the right cylindrical glass, 8 centimeters in diameter, contains water to a depth of 3 centimeters. Okay, so right now we've got this glass that has water at a height of 3 centimeters. It says what volume of water must be added to raise the water to 7 centimeters. So I want to bring the water up here to, so that distance there would be 7 centimeters. Well, the difference between 3 centimeters and 7 centimeters is this distance here of 4 centimeters. Okay, so I'm going to try to find the volume of a cylinder that has a height of 4 centimeters. That's what I need to add to get the total of 7 centimeters. So volume is pi r squared h. Pi radius is going to be 4, okay, because it says we have a diameter of 8. So 4 squared is 16, and then times my height of 4, okay. 16 times 4 is 64, and then times pi is 64 pi. So option D. Working on number 20, what is the height of the cone? Okay, so over here, what you need to do is draw in that there. Okay, now because this is 2,400 centimeters, we're going to change that to 12 meters here, and this would be 12 meters. Okay, 2,400 centimeters is 24 meters, but I only want half of it for the radius, so that's 12 meters. The slant height here is 17.5, so I'm going to use the Pythagorean theorem, which will say, this is in meters, so we got 12 squared plus h squared is equal to 17.5 squared, so 17.5 squared minus 12 squared gives me 162.25, and I'll take the square root of that. And that becomes my height. So 12.74 would be option B. Okay. So this height is 12.74. Now what is the volume of the cone? Well, remember, volume of the cone is 1/3 pi r squared h. So I go 1/3 times pi. R, we said was 12. We'll square it, and h, we just found to be 12.74. So take our calculator, multiply all that stuff out. We got 1/3 times pi times 12 squared, which is 144, and times 12.74, and we get 1921, which is option B. Number 22 says, what is the time needed to fill the cone? Okay, well, the volume of the cone is this 1921.15 cubic meters, and we are filling this thing at a rate of 2.3 cubic meters per minute. So divide this by 2.3 cubic meters per minute. I divide that out. Divide by 2.3, and it's going to take a total of 835.28 minutes. Option A. Down here it says the container shown has the shape of a rectangular solid. When a rock is submerged, the water level rises 0.5 centimeters. I told you the day of the quiz, or sorry, the day of the test, that this was without, this picture here is without the rock. Okay, so the volume of that thing is 30 times 45 times 20. Okay, the volume without the rock, or before the rock, is 27,000 cubic centimeters. So that's option B. Okay. Volume with the rock. Well, volume with the rock is going to change just the height. So I'm going to have 30 times 45 times, now the height is going to change by half a centimeter. It's going to raise half a centimeter. So multiply that together, and I get 27,675 cubic centimeters. So right now, that was B. This is A. And now the volume of the rock would be the difference of those two things, which ends up being C. Okay. Here it says a solid metal cylinder of radius 8 centimeters and a height of 20 centimeters is melted down and recast as a cone of a radius 10 centimeters. Find the following info regarding the cylinder and cone. Volume of the cylinder. Okay, well, volume of the cylinder is pi r squared h. Okay, a cylinder has a radius of 8 centimeters. So you got pi r squared would be 64, and h is going to be 20. Okay, so I multiply that out. 64 times 2 is 128. So it's going to be 128 or sorry, 1,280 because of the extra 0 here times pi. So B. Okay. Now I ask you, what's the volume of the cone going to be when I recast it? Well, matter does not disappear. So if I had the volume here of 1,280 pi cubic centimeters, it's going to be the same thing for the cone. Okay. Now the volume of a cone is 1/3 pi r squared h. So we need to take 1,280 pi equal to 1/3 pi. Okay. They say we're recasting this thing to a radius of 10. So we'll take 10. I'll square that, and now we're solving for h. Okay. When I go ahead and, I'm going to get 1/3 pi times 100 times h is equal to 1280 pi. There's several things you could do. You can multiply both sides by 3 and then divide both sides by 100 pi, and that will leave you with h. And when I do that, h will end up being 38.4 centimeters. Number 29 says, given the following, identify the following information. What's the height, or sorry, where's the length of the apothem rounded to 2 decimal places? Well, here we've got it's a pentagon. So to find the apothem, and the reason I set you out asking this question first is because we need the apothem to find the area of the base. So right now, we're going to deal with that triangle. We know that each side is 12, so that's going to be 6. And we need that angle right there where my cursor is. So I'm going to take 360 divided by 5 central angles, and then I'll divide that central angle by 2, and this angle here becomes 36 degrees. Okay. Now I'm looking for the apothem, which I'll call A. Got to use tangent, so I'll say tangent of 36 degrees is equal to opposite over adjacent. That's going to end up giving me A is equal to 6 divided by tangent of 36. Just make sure I'm in the right mode. Yep. So my apothem ends up being 8.26 feet. And that's option B. Okay. Question 30 says, what's the base area of the pyramid? Okay, well that formula is 1/2 apothem times perimeter. So 1/2 my apothem, 8.26, times my perimeter, which is going to be 12 times 5, which is 60. So multiply it by 60, and multiply by 1/2. That gives me 247.748. So option D. Okay. Now, 31 says, what is the volume of this thing? Well, volume of a pyramid is 1/3 the base area times the height. So I'll go 1/3. Base area is 247.75. Okay. And then the height is 12 feet. Okay, so I'll take this times 12 and then divide it by 3. I get 990.99. Okay. Now, my only option here, the closest one was B, and the reason, 990.99, the reason I got that is because, I rounded this a little bit differently than the 247.8. Okay. But option B is going to be your answer. The next question is, find the lateral area. Okay. Well, lateral area for a pyramid. Let me clear all this stuff here. The lateral area for a pyramid is 1/2 perimeter of the base times the slant height. Okay. Coming back and finding the slant height, that's going to be that distance right there. We know that's 12. We know that is 8.26. So L, the slant height, is going to be the square root of the sum of those two squares. So I'll take 12 squared plus 8.26 squared. And I'll take the square root of that. And my slant height is 14.57. That's simply the Pythagorean theorem to find L. So now I'll go area is 1/2 the perimeter of the base, which is going to be 60, times the slant height, which is 14.6 right now. So 30 times 14.6 gives me about 438. And the closest option there would be option C. Okay, now we're off a little bit because I use different values with my rounding, but you should have found, pretty close enough. Option C. All right. Moving down to question number 33. Let's ask you to find the volume of the outer cylinder, and we know that we have a outside radius of what, 4 inches. Okay, so that distance right there is 4 inches, and the pipe is 12 feet long, so I'm going to say this is 144 inches. Okay, so the volume of the outer cylinder is pi r squared h. So pi, radius is 4, we'll square that and get 16, and then h is 144. So 16 times 144 times pi would be option B. Okay. Now they want the, I believe the next question is the inner radius, sorry, the inner cylinder, volume of that. Okay, so that's volume, pi. Radius now of the inner one is 3. So 3, and we'll square that, multiply that by 144. So I get 9 times 144 times pi is 1296 pi. Okay. Now it says, what is the total weight of the pipe? Well, the pipe is going to be the outer volume. There's 2,304 pi inches cubed minus the inner volume of 1296 pi. Okay, so that's the actual volume of the pipe. Okay, taking the outer cylinder, subtracting the inner cylinder, and now you're just left with a pipe, okay, or a tube. And that's going to be, cubic inches. Now here it says that iron weighs 0.25 pounds per cubic inch. So I'm going to take that and multiply by 0.25 pounds per cubic inch, and I get 791.68 pounds. So it's option B. Okay. So suppose you want to cover the entire pipe in zinc. What is the total surface area of the pipe? Include the inside, outside, and the parts of the bases that need to be covered. Okay, I'm going to cover the outside first. So let's say outside, okay, it's the lateral area of a cylinder. So that's 2 pi RH. So the outside is 2 times pi. Now your radius of the outer cylinder is 4. And now the height of the outer cylinder is 144. Okay, so that's the outside lateral area. The inside lateral area, again, is 2 pi RH. It's going to be 2 pi. Radius now is 3. Height is 144. Okay. I'll come back and actually use our calculator and find out those values here in a minute. We also need to cover that area there, which is going to be the outer base minus the inner base. The outer base, outside base, is going to equal pi r squared. Okay, so that's going to be 16 pi. Okay, the inner base, which is actually the area of this hole right here, this circle. Let's color it red. Okay, that is going to be pi r squared as well. But now r of that inner circle is 3, so I'm going to get 9 pi. If I subtract those two things, I'm left with that kind of a donut, okay, that circle. Subtracting those will give me, what, 7 pi? Okay. But don't I also have one of those down here, okay, on the other end I don't know, my picture isn't very good, but on the other end, I'm going to have the same thing. So that's a total of 14 pi. Okay? So 14 pi is the area of that shaded region and this shaded region down here. Okay? What I want to end up doing is take this distance here, or sorry, not distance, but this area here, and this area here, and add them all up. Okay? So now, we've got 2 times 4 times 144. So this is going to be 1152 pi. And then 2 times 3 times 144. It's going to be 864 pi. Okay, I'm going to add those things together with my 14. So 1152 plus 864. Oh, plus 864 plus 14. And that gives me 2030 pi. So D is my option. Okay. This last one, what we want to think about here is the picture is, the way I've explained it, you basically have like 2 6-packs of pop stacked on top of one another, and you want to put a box around those things, okay, so that there's no room on either side of the box or the top and bottom of the box, okay. In order to do this, let's kind of think through looking at this thing from the top, okay, so this would be looking at my stack of cans from the top. It wants to know what is the length, width, and height of the box that you would need, okay. So the box, is going to be that box right there. It says each can is a congruent cylindrical solid with a diameter of 4. So that's 4, so that has to be 4, okay. So that distance right there is going to be 8. That would be 4, that would be 4, that would be 4, so that distance there is going to be 12, okay. Now, looking at this thing from the side, you got one can on top of another can, okay, so this distance here would be your height, okay, and they tell us that the height of each can is 8 inches, okay, so that would be 8 inches, that would be 8 inches, so the total is 16. So I'm looking for a box that has 8, 12, and 16 for the dimensions, so that's option C. Okay. What's the total volume of the box? We'll multiply those things together. So 8 times 12 times 16 is going to be 1536. So option D there for the volume of the box. Now the volume of one can. Well, volume of a can, cylindrical can, is pi r squared h. So pi, your radius of your can, be careful here, it's going to be 2. So radius squared would be 4. And the height then is 8. So I get 32 pi for one can. Okay? The volume of one can, 32 pi. What's the volume of all 12 cans? Well, whatever 32 pi times 12 is. So 32 times 12 gives me 384. So 384 pi is going to be the volume of all 24 cans. Or sorry, all 12 cans. 12 cans. 41 says, and what is the volume of the space in the box that is not occupied by the cans? Well, the volume of the box is this. The volume of the cans is that. Let's subtract them. 1536 minus 384 pi gives me 329.63 cubic inches. Each question on here is worth 2 points. Hopefully you understood why I gave it in this format. I'm trying to walk you, we're looking at these questions here. 33, 34, those questions kind of walk you through the steps to help you answer the ultimate question of 35. Okay? Down here, 37 through 41. 37, 38, 39, 40. Those 4 questions help you answer the ultimate question of 41. Okay? In the homework and stuff that we've seen in class, this would be the only question that they asked. Okay? And some of us had trouble with that because we couldn't walk through the process, the problem-solving skills, to come up with what we needed to do to actually get 329.63 cubic inches. So hopefully this format kind of walked you through those steps and helped you get there. Okay. Um, Hopefully this tutorial was useful for you, and I hope to see you on the retake.